Welcome to this explainer on the geometry of neural ignition. Okay, today we are about to fundamentally rewrite the way you think about your own mind. You know those old textbooks that told you the brain is just a biological computer made of wet wires? Yeah, we're throwing that metaphor right out the window. Instead, we are stepping into a universe of thermodynamic geometry. We're going to rethink the brain as a fractal attractor engine, a dynamic, living system where energy, information, and physics all collide to literally construct consciousness from chaos. I want to kick things off by framing our journey with a quote that just perfectly captures the mind-expanding reality of modern biophysics. It goes like this: life is a trajectory through nested attractor basins, from the hypothalamic fixed point as origin, into the strange attractor of sustained neural criticality. So what does this actually mean for us? It means life isn't just a collection of biological functions, it's a mathematical trajectory. It's this continuous, unstoppable flow of energy and information that refuses to fall silent. Right, let's dive into Section 1, the physics of life, looking at energy, information, and emergence. So, before we even talk about neurons, we've got to talk physics. Every living organism is what physicists call a Hamiltonian system with dissipation. Basically, that just means we constantly take in energy, use it up, and lose some to our environment. And here is the absolutely crucial point. Energy transfer and information production are essentially the exact same thing. Think of a rushing river. The sheer energy of the water must carve out new information in the shape of the riverbed below it. Because they're locked together like this, even a tiny amount of energy flowing through the system dramatically reorganizes its informational landscape. So emergence isn't just some lucky biological accident. Given enough energy flow, emergence is thermodynamically mandatory. Physics literally requires it. Which brings us to Section 2. The shape of emergence and the geometry of the mind. To really visualize what emergence looks like mathematically, physicists use a concept called phase space. It's basically a massive, multidimensional map of every possible state a system can be in. And in this space, living systems are gravitationally drawn toward these beautiful, highly complex structures called strange attractors. Imagine a whirlpool that never repeats the exact same swirling pattern twice, yet somehow perfectly maintains its overall shape. It's a fractal. These strange attractors crystallize at the exact geometry that maximizes information production for every single unit of energy flowing through. When you're looking at a strange attractor, you are looking at the literal mathematical fingerprint of emergence itself. For the human brain, this strange attractor sits right on the absolute edge of chaos, an operating point known as criticality. And balancing on this critical edge, it grants the brain four incredible gifts simultaneously that absolutely no other physical regime can provide. First, you get dynamic range, the ability to respond to a tiny whisper or a loud scream without going totally silent or just exploding. Second, information transmission. This allows your visual cortex to talk to your prefrontal cortex instantly without the signal dying out along the way. Third, information storage, giving the whole network a fractal memory across all possible timescales. And fourth, sensitivity to perturbation, the ability to amplify tiny differences so you can easily tell very similar things apart. Moving on to part 3, life on the knife edge, and the crucial role of the branching ratio. Now, criticality is a thermodynamic knife edge. It is incredibly precarious. Maintaining that perfect balance is a massive biological maintenance problem. How exactly does a chaotic, wet organ keep itself flawlessly balanced every single second you are awake? Well, it all boils down to maintaining one vital quantity, the branching ratio, which is represented by the Greek letter sigma. To stay right on that knife edge, sigma must equal exactly 1. In your brain, this means that every time one neuron fires, it activates exactly one other neuron on average. Not 0, not 2, just 1. That is the exact mathematical definition of neural criticality. If the brain drifts off this knife edge, things break down really rapidly. In the subcritical regime, where sigma drops below 1, neural activity just decays exponentially, and the whole network compresses to silence. Now, the brain actually visits this state intentionally during slow-wave sleep to reset its synapses. But if sigma creeps above 1, we enter the supercritical regime. Here, activity amplifies exponentially, leading to runaway saturation. This is actually the underlying physical mechanism behind seizures and epilepsy. To prevent that from happening, the brain evolves these relentless homeostatic mechanisms that are constantly pushing the whole system back to sigma equals 1. Let's dive into Section 4, the neuron reimagined, taking us way beyond the simple biological wire. A century ago, pioneers like Adrian essentially thought of the neuron as a simple computer wire, a passive relay with just a single resting state and a simple spike threshold. But modern neuroscience completely shatters that view. The neuron is an active, highly nonlinear engine. Instead of a basic on-off switch, it uses complex geometric boundaries, called bifurcations, to process information right at the cellular level. It doesn't just passively relay signals down a line. It is a tiny, three-layer universe all of its own. And get this, the neuron doesn't even do this alone. It's actively sculpted by an inhibitory network that acts kind of like highly specific bouncers at an exclusive club. You've got parvalbumin, or PV cells, standing right at the main door, setting the exact firing threshold with literal millisecond precision. Then you have somatostatin, or SST cells, managing the back rooms, selectively closing off specific distant branches of the attractor landscape. And finally, VIP interneurons are exactly what they sound like, a true VIP pass. They act as a contextual gate that only opens up specific geometric pathways when the brain decides a moment is actually important. Okay, Section 5, Scaling to Consciousness and the Escalator of Emergence. Let's watch how this actually scales up. Think of it like climbing an escalator of emergence. First, synapses couple together to create sustained dendritic attractors. Those dendrites then gate the main cell body. Next, tens of thousands of neurons lock together into a cortical column attractor, a winner-take-all state that no single cell could ever produce on its own. Columns then synchronize into broad brain area rhythms. And finally, those local areas erupt into a massive, brain-wide, self-sustaining state. Boom. This is global ignition. This is consciousness. Every single step of this escalator crosses a distinct geometric threshold, creating qualitatively brand new information out of thin air. But how do all these massive, totally different scales actually talk to each other? Well, think of it like a radio signal. The slow theta rhythm from your hippocampus acts as a broad carrier wave, providing the overall context. Meanwhile, extremely fast gamma bursts from your cortex ride right on top of that wave, providing the specific content. Basically, at the peak of that slow theta wave, the threshold for the fast gamma bursts is lowered. One attractor is literally surfing on another, seamlessly combining context and content to create your active, memory-guided perception. Now, the brain isn't just building from the bottom up. It's a fully bidirectional architecture. Your global brain states are actively reaching back down to sculpt the geometric boundaries of individual synapses using neuromodulators. Acetylcholine pushes your entire network toward that critical branching ratio to keep you awake. Norepinephrine sharpens the boundaries of the attractor basins, making your transitions fast and decisive when you're aroused. Dopamine deepens specific basins in your prefrontal cortex, literally creating the physical geometry of your desires and attention. And serotonin, that modulates exactly how long your mind dwells in any one attractor basin before finally moving on. So we've traveled all the way from the thermodynamic laws of Hamiltonian physics right up to the literal geometry of human consciousness. And it leaves us with this staggering conclusion. Cognition is absolutely not computation. You are not a computer running software. You are a biological engine navigating a fractal landscape of attractors. Which leaves us with this final, truly profound question to consider. If thinking is simply the trajectory of energy through this dynamic space, how is the physical weight of the very next thought you have going to reshape the synaptic geometry of your own mind? Thank you so much for exploring this explainer with me.